Hello. Now, let me get back to the starting point of actually any of these what do you call rapid prototyping what you call parts or anything. So, allow me to show you or refresh your memory with this. If you remember, this was one of our earliest what do you call attempts at rapid prototyping. This part was maybe made around 6 years back. Only problem is we are not very familiar at that time, especially with respect to the strength of the particular material, what is the minimum thickness, how to support it and all that. After nearly working on it for 8 or 9 years, we are only marginally better. So, I will see if I can start with, can we make some small thing like this or equivalent to that. This one is it is part of some toy laser. I am not sure what it is. If you press a button here and it was a gun sight or something. So, it sits on that. This is probably the simplest part where accuracy is not that important and the volumes are very high. In contrast, a mouse like this requires tremendous amount of accuracy. Now, I will take something via media. This one is a battery holder, okay, and ideally meant for such applications. I do not know, I do not recollect whether I have already shown you typically a small product like this. This is a modified, I will call it a prismatic object, and instead of this face being vertical, it is at an inclination. And then you see they are all just what do you call meant for an exercise. So, you have a display there, then you have 3 buttons and so on. The main feature of it, if you see carefully, is that the whole thing has been made out of a sheet, you understand, no, flat sheet. The advantage and disadvantage, advantages is it is relatively easy to make in sheet metal. Disadvantages is this is not the ideal product meant for a rapid prototyping application, especially with fused filament depositing modeling, that is you have a filament which goes up and so on. So, in real life you have several other options. So, if you can kindly look at my display here, if you see here my student earlier had made this some lamp. So, in this lamp you will notice that there are certain features, for example, this circular cap, and inside can you see there is a what do you call a cell. In this case it is directly at 3.7 volt cell. Commonly we call it a battery because inside it can have more than one cell. So, if you see that what I call toy laser I have shown, that had 3 cells all putting together, but right now lithium ion, nickel metal hydride, all these things depending on the chemistry, it can be a single cell or a battery. Now, you see here lot of this detail has been carefully worked out, and eventually we have the 3.6 volt battery, then we have an outer casing of ABS, then we have all the what you call necessary electronics inside, and finally this is the product. I will stop here. Now, I will try to get back to how to start actually making a model. Yeah, you have a look here. One of the first things you will notice is it has been started with the very basic unit. As I said, it is meant for a battery holder. On the right side, I tried to create a battery. See, I start with a cylinder which typically represents the length of the main cell, and then at the end of it we also have a small cap. See this? So, if you see here, this is how probably it is going to look. Now, only problem is, I mean, please put up with it because you need to learn little bit of that solid modeling also. You see here, now this thing funnily it has moved off. I did not want it to move off like this. When I want to do any orientation or anything, it should not move off like that. Logically it should sit back where it was. So, I go here and by using by normal what do you call techniques, I do what is called a simple union of these two objects. I understand, in case some of you are very much familiar with these things, that we can also join them together, or instead of uniting them we can what do you call attach each one of them together into a group, which is called group and ungroup, and do it. In some conditions it is valid. In this case, since it is an object which has to be also it needs some important things like a chamfer here. I see what I will do with this, using this solid chamfer command, I am sorry, fillet edge command. I will see if I can just fillet it. You see there, done. Same here. Done. You see, now it starts looking a little like that cell which I wanted to make. Right now I have done it just off the cuff. I am not taking too many dimensions, I am not doing that associativity associated with it. I just have tried to now for the first thing, no, this is not even part of the actual this device what I wanted to make, but I need it a lot so that I should know how to proceed beyond these things. You have seen this. Now once more, if you see, depending on the voltage, depending on the number of what you call contacts I require, you see here I have two contacts and I have something else also at the back here. If I now concentrate on the two contacts and I want the, let us say this is the what do you call one polarity and all this, now we end up with a very peculiar what do you call situation. So, I have a torch cell and let me say for the moment the top is positive and the bottom is negative. Next one, if I keep next, usually it is customary for us to invert it. If we invert it, positive, negative to positive, and positive will come here. Now comes the third thing. I am sorry, positive, negative comes here. If I am to take connections from the top, it is easy. Now let us say I need to add one more to make that 3.6, it ends up on the other side. Now if I wanted one more like this orientation and where you put the spring contacts becomes very critical. So in this case, for various I do not know practical purposes, they have made this. So luckily for me, invariably this will be a positive contact, negative join to positive, again I know negative join to positive, it goes like this, and finally I have can I get both of them on the same side? We see we have a problem here. Again let me trace positive, negative to positive, positive to negative, negative to positive, negative, positive and negative here. Luckily these two are on the same side, no problem for me, absolutely no problem. So if I have 3 cells, I still have a problem. Now what these people have done is, they have done a lot of, I will say, magic here. Why this magic has been made is, so that in the end this has to become compatible with a socket arrangement which is common with the 9-volt cells. I will leave it here at the moment, I will just show you how to make this. Further, if you see a little bit of detailing here, I have 3 partitions here and outside ones. How do I ensure that everything sits properly here, and then where is the place for this what you call tensioning spring and so on. I will try to see how best I can build it here. You see here now I have one cell in place. This is where the advantage of using CAD will come. So, what I will do, I will copy one with the other. Now, if you look at it in the other view, without too much effort, you have seen I have created 3 cells and where the connection is easy, relatively easy. But then we come to the other problem, saying both the positives have ended up here. Now, how to deal with it, that is where the thing comes here. But right now, to just what you call move on with it, I will see how best we can make things here. I have all the cells in one place. Now, I need to start building the cover as I would like on the a little similar to what I have seen. Now, this is where our how to tell how to collect these samples and take it from various things will come. If you see here, tremendous detailing is there, meaning at these 2 points I have curved things and a little springy also. See this little springy curved, and the center, these 2 portions are just straight with a small what you call a wedge like thing. And why it is or anything, no, it is about how well a thing like this can be introduced inside. Earlier what people used to do is try to make a mock-up using what you call polystyrene or even acrylic parts, assemble together and try it. But right now, thanks to rapid prototyping, we can still afford to do a few mistakes, 1 or 2 small mistakes. So, one of the things you will notice here is whatever that partition I want to make and how much gap I can see. See, right now I have a beautiful place here where I can start see 2 small, rather 3 small, some structures have been created here. There is a little advantage and disadvantage. Advantage is without too much of effort, I could just trace something on the screen and create these objects. Now, we will come to the next what do you call important thing, saying can we create a simple base using these objects here. That is the starting point. For convenience, I have created a section which is about 1 mm wide. It is more a matter of convenience, nothing to do with other thing. Now, you see how I will try to attach these things to that. I will use a command. Right now, this is not a command in how to create these things, that as I have explained to you earlier, you can try to, you see here all of these have been attached together like this, and now I will go for the next this thing. Having created this what you call tray like thing, which forms part of the base here, you have seen this, it forms part of the base here, base that you see here. This is a cross section which I have created right now. So, instead of these things with all this slope and all that, to make it a little faster, I have just created something which is straight, and these also have created something which is straight. Now, what I will do is I will hide these what you call this cylindrical our batteries here. Attach all these things together by a command called join. See, I have got a single line which looks like this. In a way, I am a little happy now. Let me look at it in the other views. You have seen this. And all I need to do now is go to something which creates a solid here. See, already part of my box is ready. You will notice that so far it was just about creating a box. There is no big deal about it. I have started with these what you call cells which I managed to hide. Now I will try to unhide the cells which are there. Now I need to think about how well do they sit together and do I need anything more. And one thing why I have stopped here is now we have several options on how to lay up this device. One of the things you will notice is this is vertical and relatively tall. Will it be strong enough? That is where we started in the beginning. So, if you can kindly have a look at my box here. We started like this, then we thought going by the manufacturer's specifications, we thought this is okay. I mean, because he said something about 1 mm, 2 mm and all that. Then we discovered that it is not that okay as we think it is. You see, it has developed holes because we have to be a little more careful about the numbers we choose and the algorithm the machine itself follows inside. And while that was clear, we overestimated the support required for putting this small, we have a what you call threaded insert into this. Too much of dust here, old, 5 or 6 years. Now, this is where you probably require little bit of tips and tricks and then somebody else also working with it. Now, going back to this, now you decide is this optimum making things like this or we have a little advantage and disadvantage. So, if you see here, if you see this view, the machine is going to build things like this vertically. First layer will start here, okay, something will move like this. After coming here, something, the algorithm there decides whether it should move backwards and forwards or what to do, and then how do we build up these things. This is where the total amount of material we need to save is important. So, if you put it in this condition, it will behave in one way. If you put upside down, it will behave in one way. And will it be stiff enough? And what about this profile? Is it sufficient for us? Can it really be a triangle? In reality, it will never be a triangle. You cannot make an inclined surface if you put it like this, because it depends on the layer thickness. The issue here is the layer thickness, not the XY resolution of the movement. XY resolution is one thing, layer thickness is something else. And again, in layer thickness, the way it handles the layer is one more thickness. So, it is very easy for me to complete this job here, which is where actually our main problem starts. It is easy for me to create an end cap at this point. In fact, probably the easiest of all these things. What I do is, I try to create a surface, a plane, corner to corner. Sorry. So, I have an end cap already. Unlike in regular what you call sheet metal or other plastic construction, we need not worry too much about whether it overlaps there. Say, I will just move it out a little, and then you see here, this seems to be, I have two options. I can make it sit within this thickness from here to here, or I can make it sit over the thickness here, depending on your method of assembly, method of how you want it or anything. All of these are possible. And finally, the ultimate, we now need to give a thickness to this. I will just give randomly, I will go here and then I will try to give a thickness. Well, it is as easy as that. I have created a tray like thing, I have added end caps. Now, you will notice that these end caps now, by some, I think by some lucky accident, they appear to be a little thicker than the other things. Why do I need them thicker? Because I need to add all these details which are there here. See, I have two contacts here. Okay, then I have springs here. So, those things are very easy for me to create. I will go to the side view here and then I will try to create a small circle. See, I have those peculiar things, small knobs or contacts stuck here inside like this. So, in this case they are on the inside, this case they are on the outside, just to illustrate some point. And if we were to follow that old thing which I was telling you earlier, now you see I have intentionally staggered them. Now I will try to do the Boolean operation one more time, and then you will probably now understand why see here a dent has been created on the outside. You have seen this, these two represent the dents that have been created on the outside where the connections have to come. Now for this sorry, some bomb because of the what I call some, I expect some software problem. I will try one more time. Yeah, this has come out better. If you see this, two of these have been, the indent has been made inside, the other two indents have been made outside. So, this was the what you call intention for me in creating the this thing here. This is where a little more what you call thought has to be created and what we want to do. Now, if I want to put all of them back again here, you see here, this is where the advantage for me lies. Since there is a spring here and you can have effort to have a contact, this goes forward, these two need to be moved to the other side. Contact here, spring there at the back. I am luckier this time. My object is practically ready. Like you, I am also very eager to get it printed, but suddenly I noticed that the detail is not really this thing. This is far more detailed than that what you call relatively simplistic thing which I have created there, that only had some indents here, and something up closed here, some little partition here. So, this is already available in the market, highly evolved and suitable for injection molding. Then you want to build it up for the rapid prototyping. Some of these things are not so easy to do, including this curved surface, but that curved surface is required for it to be held in place. So, how do you go about it? This is where that element of product design also is required. Now, I will just try to quickly see what best I can do, because I think you need to go back and try it yourself. I have my object ready, all ready to be printed. Very advantage of any of the solid modeling is, after looking at it, and in fact if it is very first time, you can go ahead and print it, but I see that it needs tremendous amount of refinement, especially with respect to the other metallic things which have to go into the product. So, even a routine thing like this, for example, this has some slider like thing here, something else here, okay, and there is a switch here, a switch top. You have seen this, I have a switch top. These things you can both integrate as well as take it from the what do you call this thing here. Now, you see here, for the cells to be pushed inside, lot of detailing has gone. This is a toy. This whole thing probably would have been produced for I expect some 20 cents. It is cheap. So, by our standards, it comes to maybe 20 cents is what do you call 1/5 of 60 is around 10 rupees. Okay. This whole thing has been, including probably the what do you call all the electronics inside and all, for about 10 rupees. This is where it is possible for you to optimize by going back to the model there. I will just now see one small very minor thing. I will see if I can make the thing improvement, and then I will try to just to make it simple and fast. Lucky again. You see, all the sharp corners have been removed. You see here, and this actually starts looking a little more like the model's real life things. You see there, you see the corner, and you see here what happens to the corner. Now comes, this is where your ingenuity and various other things will come. Once again, have you noticed this face is thin, looks fragile but serves the purposes. This intentionally has been made 3 times as thick, because this is where the force of all the electrical contacts and all come. This is incidental, just to see that it does not roll about, and to minimize the material we can do whatever we want. Other options are also there. Do you need to make it like this, or can you give some curved what you call half circular things by which it can sit inside. And finally, is it possible for us to make like before two halves? Luckily for us, in the case of this rapid prototyping, optimizing by making two identical halves and joining together does not arise here. It is a question of can we open it, load our items and push it inside, which was not possible earlier, which is very much possible now for us. So, at this point I will try to stop here and see whether you see here we have options. Right now it is by default it is moving at a particular speed. So, after you become a little more what do you call, it is very much possible for you to play around and see everything that is possible. Would you like to keep it like this? This is where the difference between injection molding and our thing comes here. Whenever there is a change in cross section, injection molding has a chances of shrinkages occurring on the other surface. Right now I will see as best I can tilt it towards it. Can you see at this point? Now you can see some grooves like thing here, groove. 1 groove, 2 groove, 3 grooves. These grooves typically are the result of change of cross section here. We need not worry about it in rapid prototyping. The other phase, because it starts by laying up, will look absolutely as clear as possible. And in fact, we can add any other texture preferably with small dents and all that. So, permit me to stop here so far now what we have come. I will continue with this in the next what I call half an hour. So, thank you.